My name is Wojtek Kalicinski. I'm a developer advocate in Google London. It's nice to be here. First time as a speaker. I actually have been here, I think, 2 years ago at DevFest, just as an attendee. So nice to be on the other side now. And this is a presentation that was really made ad hoc for DroidCon London for the bar camp. So it's a bit random. It's basically we're going to be jumping from one topic to another. And these are tips that I collected during the past few months on what mistakes developers make in their apps, and what can be made better, a few ways how to optimize your app. The template that I used has this agenda slide, so I decided to use it since it's here. So the agenda is we will have tip 1, then we will move on to the second tip, then the third tip, and we'll see how many we can actually fit in this talk. I don't promise you 20 tips, we'll see. But actually, we're going to talk a bit about how to optimize your app for startup time, battery life. Pretty much everything here will affect battery life at some way or another. We'll talk a bit about performance, about APK size, and like I said, some other random stuff like sharing and accessibility. So let's start. My first tip is don't run your code. If you want to save your user's battery, memory, CPU, just stop running your code all over the place, like every opportunity, all the time, and so on. And tip 1 is pretty obvious. I'm pretty sure every one of you should know that already, but I still have apps on my phone that just don't follow this one simple rule. Stop your services when they finish their work. It's a bit obvious. If you want to have a very simple mechanism to do that, just use an event service. It's a platform component. It's available since like forever. Just be mindful that it can only process one job at a time, single-threaded. So if you need anything more complicated, you will have to probably program it yourself or find a library. But moving on, still about not running your code. Think about this. You probably use application on create for a lot of things. This is a mistake I used to make in my apps. Like I put everything in there that I will use at any point in the life cycle of my app. So I would put things like, I don't know, initializing the database, or even loading it into memory, like some prefetching some data from the disk. I would kick off downloading fresh data from the network, from the server, like the synchronization. I would go through my file cache and see if I have old files that I want to delete to save some space. Refresh auth tokens, so again, network requests. So all this involves a lot of memory allocations, disk access. You spin up threads, because obviously you can't do things on application on create on the main thread. So you spin up threads, you take up the CPU cores. And of course, network. You download stuff, you kill the battery really fast. And so the thing is, these things don't only run when someone clicks the icon with your app. These things also run. Oh. Do I do something or? Okay. Can I still click through? Yeah. These things also run every time another app requests some data from your app through a content provider. Every time a broadcast receiver that you've registered fires. So if you, for example, listen for network, the network changes, it will run for every single connection, disconnection, connecting events, everything, all the time. All this code in onCreate will run. So just don't do that, please. And just don't do unnecessary work, really, because obviously there's things like really small pieces of code that you can put in onCreate that will help you just manage the state of your app. But whatever you can, remember to just defer it for later. Lazy load stuff, lazy init components, and schedule jobs that you need to do frequently, smartly, using the job scheduler. Believe me, the users will be more happy if their battery stays longer for a longer time. Tip 3, not many people actually realize that you can disable broadcast receivers during runtime. So even though it's in the Android manifest, so you think like it will run all the time, you can actually go and disable it in the package manager. So if, for example, a user decided that, I don't know, he doesn't want to periodically download some kind of messages from your server. Maybe you're listening for network broadcasts to figure out when you can do that. If the user doesn't want it, just disable it. You will get rid of all those superfluous calls. Okay, moving on. Another random thing that we're going to talk about, be smart about sharing data. So it really pisses me off that so many apps get that wrong. Apps that I use every day. Sharing, the most important part of Android. We have intents, we have apps that can work together. One app can request data from another, which can have the data in the cloud, whatever, on the disk, wherever. It's a photo, text file. So I choose the file I want to share with the other app. I press OK, and the first app crashes. That's because the sharing app put the file on external storage and shared the file link, the actual file path. But what if my app doesn't have access to external storage? What if it's in the other's app private directory, or I just don't have the necessary permission? So don't do that. Don't be a bad sharing app, and just implement it correctly using a content provider. So if you share a content URI, I will show the code in a moment. You can actually grant the other app access to that specific content URI at runtime for this one-time exchange where the requesting app can actually access the content, no matter where it is, if it's in your internal storage, external storage, whatever. And for that, tip 4, share using content providers. And there is a file provider in the support library, ready to use. Just put it in your manifest. There's a few lines that I cut from here, but it's all in the documentation. There's not much coding to do, and you will get it right if you use it. So then, when you use this content file provider, the sharing app has to just make sure that it shares it correctly. So instead of sharing the file path, the file URI, just convert it to a content URI, set the file grant read URI permission. That will grant the requesting app access to this path. Set the data and just push it to the other app. But if you're actually writing the receiving app, the one that requests data, you have to remember to handle these type of links correctly. So don't expect it to be a file. It cannot be. It doesn't have to be a file. It can come from wherever. The only thing that matters, if it's a content URI, just get the content resolver and open it in full-screen. Read it, copy it to your app, or just use it once, whatever you want. On the other hand, you can also be a nice receiving app, and if you actually get a file URI, because that's also possible, it's not always like a mistake or wrong. Just be sure before you try to open it that you actually have the necessary permission if it's on external storage, and just make all the necessary checks if the file exists, if you have access to it, and so on and so forth. One thing I'm not sure about that, but I think this type of sharing will not work between multi-users because they might have different virtual external storage. So it's always better to use content URIs, but just remember that this is a perfectly valid way as well. I mentioned permissions. So yay, we have runtime permissions in Android Marshmallow, and Android permissions are awesome. They're super simple to implement. Just request a permission, implement the callback, and you got it. It's simple. Yeah, perfect. This is actually one thing that we're advocating. If you don't have to have a permission for something, you can actually use an external intent again to ask another app to provide you with the data you need. Like everyone has a camera app on their phone, right? And the camera app will have probably the camera permission. So your app doesn't need it. Just ask the camera app to provide the photo to you. Then you can just do that. But like I said, they're simple to implement until they're not. So there are a couple of caveats that I want to tell you about. So about that camera permission. So this permission is different than all the other permissions in the runtime system. So normally when you put a permission in your manifest on Android Marshmallow, we're still talking about Marshmallow here. If you put a permission in your Android manifest, it doesn't change anything until you actually get that permission at runtime. With the camera permission, it's different. So if you want to use the Media Action image capture intent to get a photo from another app, this will throw a security exception if you put the camera permission in your manifest but you don't have it in runtime. So there's two other ways to say it. If you don't put it in your manifest, then you can use it without any runtime permission checks. Or if you want to use camera in your own app and ask for it externally, you have to have it both in the manifest and get it on runtime. A bit complicated, but that's why I'm here to tell you about it. Another tip. So, you know, was it from Jelly Bean, I think, or I don't know which version, but basically your app doesn't need the right external storage permission to write to its own private external folders. So there's a couple of methods on the context that give you a folder on the external storage that your app can use as its private space for its files. You don't need a permission for that. We're used to it, so we don't check if you get an exception or something. You're just used to writing files there. But actually, if you have an app that you haven't upgraded to Marshmallow yet, so the app is targeting Lollipop or below, and you install it on an M device, and the user goes into settings and revokes the right external storage permission, it turns out that your app will lose this thing that we take for granted, so it will not be able to write on external storage at all, even in private folders. So just remember, if you're still not ready to move your app to Marshmallow, test against that, see how it behaves. And same with every other permission really. Just install your app on an M device, revoke every single permission, and see if anything crashes. Because we did our best to provide like mock data. So for example, if you revoke contacts, you will get an empty contact list. But in some cases, if the developer made some assumptions, things can break. Another tip related to permissions. Android permission get accounts, hated by many developers right now because it actually belongs to the contacts group. So if you need the get accounts permission, what the user will actually see, allow this app to access my contacts. It's a little bit misleading and it's a little bit too much really. But it turns out that on Marshmallow you don't always need this permission, whereas on previous version you would need it. So on Marshmallow you don't need it if you only work with your own accounts in the account manager. So only your apps or other apps signed with the same certificate, then you don't need the permission. It's only when you want to access other apps' accounts that you need it. And the most usual case would be Google Plus sign-in, I guess. There's a few methods like get account name or get token in the Google Plus sign-in that still need this method. But there are ways around it. So you can use the account picker that will display like a system dialog to the user, letting him choose the Google account that he wants to share with your app. And that doesn't need the get accounts permission. And it turns out that once you have the account, you also will not have to use the other methods in the Google Plus sign-in that required it. So it's pretty handy. And since I made this presentation a couple of weeks ago, we actually have a new Google Play Services version. So if you upgrade, there's actually another sign-in flow that's a lot simpler both to implement, and it's simpler for the user. It's less dialogues, less clicking around, and that works without the get accounts permission as well. And it shares like basic data like email with your app. Okay, moving on. Now we're going to talk a bit about performance. Anyone of you watched performance videos by Colt? Lots of people. Okay. I don't usually work with performance. I'm more of an Android Studio and tools guy, but it's kind of my thing that I like to do as a hobby. So yeah, believe it or not, there are phones with 512 megs of memory. And tip 9, this is old stuff. You probably heard it at last I/O or even the one before that. So we have a new KitKat API on the Activity Manager, and it's is low RAM device. Remember to use it. If your app is really memory intensive, remember there are phones out there who can not be able to handle that. So if you encounter a low memory device, you can disable some features of your app, or maybe use smaller bitmaps. I don't know your app, so you think how you can manage that. And also, there's this callback system on the application object. So when the system is running, low on memory, it will start calling your application and telling it, look, trim some memory, lose some stuff. We need to reclaim some RAM, and do implement those. Not many developers do, and the system will only ask nicely once, and then it will just kill your app. So it's for your own good and for the happiness of your users. Another thing, so this was all stuff, right? KitKat. There are phones with 512 megs of internal storage. Yes, there are. And in countries like Indonesia and India, emerging markets, there are lots of phones you probably have never seen or touched in your life and never tested on them. And you might want to optimize for those users as well, especially since there are millions of them. And one thing, phones should really have, phones with Android that are certified for Google Pay services, should really have 1.5 gigs of internal storage for your apps. There's a thing called an Android compatibility definition document, I think, CDD, that's publicly available. Go and read it if you've never found it before. It basically lists all the necessary or required or even just proposed hardware and software specifications of every Android phone that an Android device has to have to be certified for Google Play. But nevertheless, there are devices in other markets that you might still want to target that don't have Google Play on them. And another thing is, really, there's no difference between 500 megs and 1.5 gigs. If a user starts installing apps, starts downloading music, movies, it doesn't really make any difference if there's a gig more or not. You should still optimize your apps for size. So we talked a little bit about the application memory footprint, and there are ways to reduce it. There's lots of videos on that. The other thing is APK size, right? So how much the app would, how much space the app would take up on the device when it's installed, but also how much bytes have to be pushed through the network to install and to update the app. And that's also, again, in emerging markets, that's a thing that people really care about. And if you don't optimize for that, and that's what normally developers want. They want the app to be updated. They want the users to have the newest version with fixed bugs and so on. But it turns out the users will just not update it because it's too expensive for them to do, or they have to find a Wi-Fi spot somewhere to do that. And let's talk a little bit about the installed APK size first. So the main components of an app: Java code, native code sometimes, and assets, all the graphics, sound files, XMLs, whatever you have there. And what happens when an app gets installed on the device? Now that we have the ART compiler that does ahead of time compilation, since Lollipop, when your app is installed, the compiler actually takes the DEX file that is in your APK, compiles it, and outputs an out file that it puts on the file system. So that's one thing that takes up space on your device. If you have native code in your APK, an APK is a zip file basically. We want to have quick access to the native code so that it can run at runtime. So at install time, it gets decompressed from the zip file and again put somewhere in the file system. So basically it takes up twice the space, right? Once when it's compressed and then even more when it's uncompressed. And it stays like that. Things don't get deleted from the APK. So that's kind of a waste, right? And then we have assets, and we have assets optimized for various screen densities, languages even. So these take up lots of space too. So first, there's not really much we can do with the Java code. Well, there's ProGuard, so that will minify your code a bit. It will strip unnecessary code, unused code. It will rename all the method names and class names, so that makes it a little bit smaller. But there's not really much room for optimization here. I'm sure there's some people maybe who know some pretty advanced techniques that I don't know about, but the best thing you can do is just enable ProGuard for your build. For resources, we have lots of stuff out there. We have multi-APK, so the Play console supports uploading various APKs for different screen resolutions and so on. So there is support for that in Android Studio. Again, you would have to go and just read the docs. Also, as part of the tools, we do lots of modifications around PNGs and images. So that's that. But what can we do with native code? I don't know if many of you use that, but it's very many game developers use it for sure. But even apps often have a native component. And this is one thing you might not know about. There's actually a new attribute on the application tag for in Android Marshmallow, and it's extract native libs. And if you set it to false, this decompression step will not occur. So you save space by having the native code only in the APK. It doesn't get copied out and stored in the file system. But there are some requirements. So you have to make sure the shared object files are stored in the zip file in the APK uncompressed. And the second thing is they must be page aligned so that they can be easily accessed through memory mapping by calling the zipline -p command. It's new in one of the newer build tools. And then you don't have to actually go and change anything in the code. System load library just works. It just finds the file in the APK, does all the stuff for you. The only thing is, there is no tool support for that yet. I've been bugging the Android Studio team for months now, and I'm pretty sure it's coming, but right now the best thing you can do is just take the output, the final APK, and prepare a script or a Gradle plugin or whatever that fits in your build environment, and just go and do that manually. So how it works is, first you have to actually delete the SO files from the APK. Then you am I correct? Yes, you have to delete them. Then you have to add them, but with a compression set to 0 so that they're not compressed, and then run zip-align. I think you can do all this without re-signing because the way. So a little bit of a I could sidetrack here for a little bit. The way Android signing works, it works on the uncompressed, the result of uncompressing your APK. So you can actually change how the files are compressed and how they're aligned, and it doesn't really need re-signing because that doesn't change the uncompressed contents of the archive. Okay, so we have that covered. But there's actually a little bit more you can do if you're willing, again, to not rely on just the tool support, but you want to write your own scripts or plugins for your build environment. Okay, something else first. Yeah, sorry about that. If you're worried about storing uncompressed native libraries in your APK, because obviously they're uncompressed, so they take up more space, more bytes to push through the network, and I just said that we want to optimize for that. So how does it help? Well, yes, the install time at first might be a little bigger. The first install might take a little bit more bytes to send, but Play Store actually supports Delta updates since like years now. And it's actually storing native files uncompressed helps the Play Store figure out the delta between two APKs a little bit better. And every update that you make will actually be less bytes sent to the device after that first install. So that win on both fronts. And I began saying that there's more you can do if you're willing to mess with the build tools a little bit. And there's actually -Z option for zip-align as well. So if you're doing zip-aligning for your native libraries, you might as well look into that. And it actually takes all the files in your APK that are already compressed and recompresses them with Zombly, which is a compression algorithm made by Google. It's slower, but it produces a more optimized compression. It's compatible with the old deflate that's used for every zip file. And it'll make the whole APK just a little bit smaller. You can expect like maybe 5% gains, but if you have a big APK, that's always something that counts. And another thing is, that's from Wikipedia, PNG uses a non-patented lossless data compression method known as DevFlate. So there's another opportunity you can take. And since inside the PNG, the actual image data is also compressed with DevFlate, you can go and optimize your PNGs with Zopfi as well. You can't do it after you build your APK because you will actually be changing the files inside so that they are smaller. But if you can do it before, if you can put optimized PNGs in your drawable directories, there might be big winnings. Like when our framework team started messing with that, this is a quote I took from one of the emails on that thread. They took off almost half a meg just by running Zopfi on the emoticon images in the framework. So if just emoticons can give, emojis can give that many savings, imagine what it can do for apps with like really big images. But that's a pretty advanced technique, and I won't be showing any code because it all depends on your build system, how you provide and prepare resources. And last thing, accessibility. Tell me, how many of you plan or test for accessibility in your apps? Not many people. That's what I thought. And accessibility is really important. It's just doing the right thing. And you actually get one nice bonus for it, which I will talk about in a bit. Do you know TalkBack? How many people have seen or used TalkBack? A little bit more. Yeah, so it's there. It's in the system, at least on the Nexus devices. I don't know if it's on every phone, but you can just install it from the Play Store. And it's both an accessibility tool with people with actual disabilities, but it's also a great debugging tool. And every developer, when he prepares his app for release, should go and run it and just try operating your app with TalkBack enabled and see what happens. You should really do that, and you'll see it's a learning experience. And there's 2 tips about making your apps more accessible. Well, there's 3. First of all, follow all the best practices, and then you won't have to do a thing. They will just work. The second is about Android content description. Android Studio will complain if you don't add descriptions to your images, your image views, and other things. Don't ignore it. It will just take a second of your life, and it'll make maybe lives of many people using your apps better. So first of all, set it to something meaningful for images that represent buttons and so on. One advice: when an image, for example, says next and it's a button, don't put next button in the content description, because TalkBack is actually intelligent enough to know that it's a button. So then it will say, when you put your finger on the button to hear what it is, it will say next button. So don't do that. That's one advice. And the other thing is, when there's a decorative element, an image view that doesn't serve any purpose for navigation whatsoever, just be sure to set a null. You will get rid of the Android lint that will tell you have not set a content description, and it will also actually tell TalkBack to just ignore it. And it will not try to make up stuff like that's an image or a button or something. It will just ignore it. And the other thing is, if you do any custom touch processing, so if you have a touch listener that captures various things, and then maybe it also captures a click and does some action on it. Don't put the actual implementation of the click in your like touch logic, because accessibility and things like TalkBack, when you click on something, they actually call view perform click. So if you put it in the touch listener, it probably won't get called. So test it and put your actual logic where it belongs. And the bonus is, if you implement accessibility for your app correctly, we have this new assistant now on tap, and we have other assistants that use the Assist API. If you do all that, if your app is actually browsable and discoverable via Assistant, then you don't have to, via the accessibility API, then you don't have to do much for it to be also discoverable for assistant apps like NoTap. They will just see the hierarchy, see the views, they will know what the content is, and they will figure out what they can, suggest to you. And thank you, that was 17 tips actually. For more tips, please follow Android Developers, where I post tips sometimes, and my colleagues Ian Lake and Joanna Smith also post tips on Wednesdays and Thursdays, I think. And if you have any questions, please ask now, because I have a train to catch and I won't be here for the fireside chat, so I'm sorry. I'll hang around for half hour, let's say. So ask now, find me later, and I'll be gone in an hour, so last chance.
Thanks. Thanks a lot for the nice talk. Talking of content descriptions and accessibility, we have to translate that too, right? If we provide for different languages, this is a kind of a huge additional effort, and it's the question, who's gonna see that in the end?
Well, yes, you should. You can use the normal mechanism. Like if you have a text view that has some text, you have to translate it, right? Exactly the same with content description. So, for example, blind users will not see your text view. They will hover the finger over elements on the screen, like an image view, and it's nice to provide them with at least some information so that they can navigate your app and know what it is about. Of course, maybe if you have like a gallery, you don't have to like make up stories about the images. Maybe just say for every image like image accompanying the news story or something like. You don't have to tell a story of what's on the image. It's all up to you really, but just make sure, just close your eyes, use TalkBack, and try to use your app, and then it will help you decide what is really needed and what is not, to optimize the amount of work and translation that you have to do.
Thanks.
Hi, quick question about the multi-APK size you mentioned for resources. Can I apply the same thing for native libraries and multiple architectures?
Yes, exactly. So there's two ways. You can either have a fat APK with all the SO files for various architectures, but obviously that's a waste again. Of course, you can produce APKs for x86, for ARM, and so on. Upload them to the Play Store, and it'll intelligently select which devices to deliver the APKs to. Please do that.
Hi, I wonder about the image compression with Zopfli. Is that actually more efficient than OptiPNG?
There are some PNG optimizers that actually use Zopfli. I don't know if OptiPNG uses it yet. I think AddPNG or something does use it. So yeah, you can find tools that will do that for you.
Okay, thanks.
This might be, by the way, implemented in the actual build that we have in Android Studio at some point. I don't think it is right now, but since we do PNG crunching, and we do use one of them, either we use OptiPNG or something else, I don't remember. But it would be nice if it was done for you, and I'm pretty sure it will, but I can't commit to anything, I'm sorry.
Hello. I just wanted to mention one option for shrinking the size of the APK is shrink resources. You didn't mention it. It removes resources that are not used, but I think I've had problems in one version where it's 40 devices, but I think it's fixed now.
Okay, yes, so as part of the build, yes, you can remove unused resources, but just remember that if any part of your code gets a resource by name, then the build system might not know that you're actually using it. Like there's a method that you can dynamically get an ID of the resource. Normally you say like r.drawable.something. That's obvious, but if you get it dynamically, that some resources might be removed that you still want to keep there. Any more questions? Okay, well, I'll hang around for a while, and thanks for listening.